So now we're going to start section 4.1, which is about extrema on an interval. And so our goal in this section, what we want to do is we want to find the maximum and minimum values of a function f of x on an interval I. So in general, I for us will be most often a closed interval from a to b. And so let's first talk about what these two words even really mean, what a maximum means and a minimum means on this interval I. So I'm going to define what those actually mean. So the definition, let's suppose I have a function f that's defined on an interval I containing C. Then in order for f of C to be a minimum of f on I, if, well, it needs to be smaller, so f of c needs to be less than or equal to f of x for all x in your interval I. So it needs to be the smallest value, smallest output value for your function on the interval. And then you get something similar for maximum. So we would say f of c is the maximum of f on I if f of c is greater than or equal to f of x for all x and I. So it needs to be the largest possible output value for your function. Now there's a lot of different terminology that's used that all kind of means the same thing. So I'm going to go over that part now. We say the minimum and maximum of a function on an interval are the extreme values, or another word that's used is extrema. And we're also going to say that the minimum and maximum of a function on an interval are also called absolute minimum and absolute maximum. So you'll see that these different terminologies are used. Extreme values are extrema, but you might also see absolute minimum and absolute maximum being used. So the next thing we're going to talk about is something called the extreme value theorem. So I said earlier our goal was to find these minimum and maximum values for my function on an interval. But why do they even have to exist? Or do they exist? And this extreme value theorem says, yes, they exist, as long as I know that f is continuous. If f is continuous on my interval AB, then f has both a min and max on the interval. So it's really important that your function be continuous in order for you to be guaranteed to have a minimum and maximum value. So you could look at an example like maybe a polynomial function. Polynomials are continuous everywhere. And you could look at the graph of this function. I'm just going to sketch really quickly a rough outline of what this graph looks like. So a real quick sketch, if you ask your calculator to, or a program to sketch it, you'll see that you get a graph that looks like this here. And so we call this point right here, this isn't an overall maximum, but nearby, close to that point, it's the largest value. So we're going to call this one a relative maximum. And again over here, this isn't necessarily the lowest value because this function does continue on down here. But right around that point, it is the lowest value. So this would be called a relative minimum.